Okay, today I will be covering four important concepts. Uh, Subject is mathematics in machine learning. Okay, so let me share the screen. Fine. Mathematics in machine learning. Today I am going to discuss before I proceed to syllabus. Uh, I will discuss four important concepts today. One is AI, artificial intelligence, machine learning, ML, and data science. Before that, we have deep learning concept. Okay, so mathematics in machine learning. This course is all about regarding in the course we are going to discuss theory part. Okay, and before I directly go and discuss the syllabus, I will be covering these four important points, and then we will discuss the syllabus. Okay, so you might have heard about artificial intelligence, machine learning, deep learning, and data science. But most of the students may not understand what exactly the difference between these four important concepts. Okay, so I'm going to begin with artificial intelligence. See, artificial intelligence, it is a kind of application where a machine can take a decision. Okay, like human, we can take the decision by own, like machine will take the decision. This kind of application is generally called as AI application or artificial intelligence application. So here, machine, they are making machine to understand or to take his own decision. Okay, so we are making machine artificially intelligent. Okay, so what are the examples of AI application? One is I can say the self-driving car. Okay, this is very good application, AI application, where the car is going to take a decision, right? When to apply the brake, right? When to slow down the speed of car. So everything is under the control of machine, under the control of car. So this is a kind of AI application. So ultimately, the goal is to understand, to create artificial intelligence application. Okay, and let me draw it so that you can understand. So consider AI is a kind of circle. Okay, so let us consider that the circle indicates AI. Okay, artificial intelligence, right? So as I talked here, the final goal is to create an AI application, artificial intelligence application. I talked about example of self-driving car, right? This is a kind of AI application. Now, what is a machine learning? See, machine learning is a subset of AI, artificial intelligence. So, machine learning is a subset of artificial intelligence. Now, what it does? Actually, it provides us a statistical tools to to understand, to explore, to analyze the particular data. Okay. So what we are doing, we are making machine to understand, right? So we have different kind of algorithms. Okay. Generally, it is a subset of AI application. So before we go and create AI application like self-driving car, we should have the knowledge of how we can train the machine. Okay, so we have different kind of approaches. The very first approach is supervised machine learning approach. This is a case of supervised machine learning approach where we will be having the past label data. Okay, and based on that past label data, we are going to find out the output. We will be categorizing the past data. Okay, let's say suppose we have two important features. Let's say height, and let's say we have weight. So these are the two important features in our data set. Now data set it is a kind of it can be in textual format. Okay, and we have the list of data, means these are the two features in the data set. We have the height and we have the weight. So based on these two features, I want to predict whether the person belongs to obese category or fit category. Okay, so I want to predict whether person belongs to obese category or fit category. Okay, so here this is a kind of machine learning approach. So here we are going to learn the machine. We are training the machine. Okay, so we have very first approach which is called as supervised learning, where we have past label data in the data set. This is past labeled data. Okay, so we have height and weight in my data set, and I will be predicting, means machine learning model will be predicting the category of a person, whether he belongs to obese category or the fit category. Okay, so this is a case of supervised machine learning approach. We are making machine to understand, to take his own decision. So we are making them to learn. Okay, so this is a one kind of approach. We can take one more example. Let's see. Suppose we have different coins with us. Let's see, and we want to predict the currency. Okay, we want to predict the currency of uh, a coin, right? Whether it is a 1 rupee coin, whether it is a 2 rupee coin, okay, or whether it is a 3 rupee coin, right? Or we want to predict the currency, right? This is what output we want. So we have past data. So let's say in the data set, I'm having two important features. Let's say weight, okay, and we have let's say we have only one feature, weight. Okay, so based on the weight, we are this model is going to predict the currency of a coin, right? Whether it is a 1 rupee coin, whether it is a 5 rupee coin, like this. Okay, so we have the data like this in my Excel. Let's say I'm just going to open the Excel. In my Excel, let's say in my this is data set. Okay, this is data set. Okay, and we have one feature in my data set. Let's say weight. So weight of what? Weight of coin, right? let's say we have, let's say 3 gram coin. Okay, 3. So weight is generally, it is measured in gram. Okay. So I'm having this particular feature in my data set. These are the weight. So 3 rupees, 3 gram. So 3 gram is a what? It is a weight of 1 rupee coin. Okay. It is a weight of 1 rupee coin, right? So let me write it down here. We have, when the weight of coin is weight of the coin is 3 gram, then we can say it is a 1 rupee coin, right? If it is a 7 gram, let's say if the weight is 7 gram, then I can say it is a 5 rupee coin, right? Like this. Okay, so in my data set, I am having weight is a feature. This particular heading is, this particular term is called as feature. Okay, so this is one feature, right? So based on this one feature, weight feature, what my model is going to do? My model is going to predict the currency of uh, currency. This is what can I say? This is my machine learning model. Okay. Okay, let me draw it so you can understand. Fine. Okay, so this is my uh, model. Let's say supervised machine learning model. Okay, and there is a one input called weight in my data set. Weight is a kind of feature. So weight, and based on the weight of a coin, my model is going to predict the currency, whether it is a 1 rupee coin, 2 rupee coin, or 3 rupee coin. So in the supervised machine learning model, we have previous data, okay, with us, and based on that previous data, the model is going to predict the currency. Okay, means output. That model is going to predict. You know, so this is what the, either it may be the 1 rupee coin, okay, or it can be a 2 rupee coin or 3 rupee coin, like this. Okay, so this is a case of machine learning. One very first approach we discussed. There are basically three approaches of machine learning. So we can have supervised machine learning model, we can have unsupervised machine learning model, and we have semi-supervised machine learning model. So let us take one more example of supervised machine learning model. Let's say I am having the data set. Let's say I'm having the data set, and in my data set there are two features. Let's say uh, age and height. Okay? So these are the two features, right? Let's say age is somewhat 5, then height is 47 centimeter, age is 7, then height is 52 centimeter, like this. I may have the values in the respective column. Okay, so this is a kind of data set. Okay, and based on the data set, this is input to my supervised machine learning model. And what my model will predict, this is my model. Let me write it down. Supervised machine learning model. My model will predict what is the means age. It will predict the height based on age as well as height. It will predict whether that boy is of 8-year old, 10-year old, or 15-year old. So based on this two features, the model will predict whether the person, or let's say the boy, is of 8-year old or let's say 10 years old, like this. Okay. So this is a case of supervised machine learning model where the model is going to act on past data. See, we have past labeled data. We have past labeled data, right? So here we know very well that there are some ages and few heights with few heights are there in the data set. Based on those two features, the model is going to predict whether the boy belongs to whether he's a 8-year-old or 10-year-old. So this is what a very first approach of machine learning, supervised machine learning approach. I already talked that machine learning, it is a subset of AI application. What is AI application? Let's say self-driving car. Okay. So finally, the goal is to create the AI application. But before these AI applications are going to take their own decision, like human can take a decision, right? Making machine to become intelligent enough so that machine is going to take their own decisions, right? And in order to make them understandable, we have machine learning approaches. Okay, so we have three different kind of machine learning approaches. Second one is unsupervised machine learning approach. Now this is a case where we means the I will not be having any label data. Okay, label data, right? It means I will not know the output. In previous case, I know the output whenever if the boy age is 5 and his height is 47, I know very well this the age of that boy becomes 8 years, right? So I know very well what is the output for particular input. And later on, then when I'm going to give the different values, let's say 12 and somewhat 85 height, my model will predict the age of that boy like this. Okay, like this. So here in supervised, I'm having the label data, I'm having past label data. But in the unsupervised learning, i I won't have the label data. So here we solve this kind of problem. We have clustering kind of problem. Okay, so we have different type of clustering algorithms. We have k-means. Okay, we have k-means clustering algorithm. Okay, then we have hierarchical clustering algorithm. Okay, and finally DB scan clustering algorithms. Okay, so these are the different. So basically, unsupervised machine learning will solve the kind of clustering problem. Okay, so here we have. Let us take one example. Suppose we have. Let's say we have runs. Let me open the new. Okay, fine. Suppose we have the data set like, let's say, number one is a, let's say, the name of let's say the person, and how much runs he has scored, and how much wickets he has taken. Let's say the player one, and player one, his name is ABC. Let's say he has scored 500 runs and he has taken 13 wickets. Okay. Similarly, we have the kind of data, let's say 200 runs, and let's say he has taken 20 wickets. So based on this particular data set, what we are going to predict. So we don't know the output. See, we don't know the output. This is the case of unsupervised, unsupervised machine learning approach. This is the case of unsupervised machine learning approach. Okay. And what is the output of this machine learning approach? Let me. Okay, so this is a input data set, and here we are the output is not predicted. See, here this particular approach supervisor is not there, right? So we don't have the label data. Okay, so we are going to predict, we are going to cluster whether that person is a batsman or that person is a bowler. Okay, like this. So what we can do, suppose this is a case where, let's say, I'm going to represent it in XY plane. Let's say we have in Y-axis we have runs and in X-axis we have wickets. Suppose based on the data set, I consider that these are the dots. I'm getting the values from the data set. Okay. And let's say, fine. And another cluster I'm getting here, let's say like this. So what is the meaning of these two clusters? The person who takes more wickets, see, and score less runs, see, the person who takes more wickets, say more wickets, and scored less runs means he is a bowler. So I can simply cluster bowler, right? And here the person who is taking less wicket but scoring good runs means he is a batsman. So what my unsupervised model is going to predict. So this is what the clustering problem the model will solve, right? So this is the case of what? Unsupervised machine learning model, where the we do not have the past data, and here we are going to predict the cluster. We are actually, the model is making the cluster, okay, and predicting the output, that whether he is a bowler or a batsman. This is what the unsupervised machine learning approach, where we do not have the label or the past data. Okay. The third category of machine learning is called semi-supervised machine learning approach. Semi-supervised machine learning or reinforcement machine learning approach. Reinforcement machine learning approach, where, see, in my model, if we draw the model, let's say we have the model, okay, where suppose now I'm going to give dog, okay, dog image, and my model will output as a cat. Okay, so what feedbacks I'm getting here, which is wrong, right? So it will give feedback. Based on the feedback, some other time when I give the dog image again, my model will predict as a dog. So this is a what feedback kind of approach, where some part of the data is labeled and some part will not be labeled. So model is going to learn based on the past data And again, when new data is coming, it will predict it correctly. So this is a what reinforcement learning. So initially, the model will not give the correct result, but after, later on, after training the by different inputs, the model is going to predict the correct result. So this is a case of reinforcement learning. Okay. So what we discussed till now, we have started artificial intelligence application. What do you mean by artificial intelligence application? A machine, we are going to make them artificially intelligent so that machine is going to take their own decisions. Okay. What is the example of AI application? We have self-driving car. This is the one kind of AI application where the car is going to take the decision by own. Okay, so driver will not be there, right? And in order to make them artificially intelligent, we should have some sort of, we should have a kind of knowledge about machine learning. So what is machine learning? Machine learning, it is a subset of AI, artificial intelligence, right? So in machine learning, we have three different approaches. One we discussed, supervised machine learning, unsupervised machine learning, and we have reinforcement learning, semi-supervised machine learning approach. Generally, supervised machine learning approach, we have labeled data. So we know very well for a particular input, what will be the output. So whenever we give the new input to the model, the correct output. But in unsupervised machine learning, what we have discussed the example of we have the data set like runs and wickets. So based on this particular data, what my model is going to do, if I draw the graph, okay. So my model is I'm getting some sort of dots here. See, I'm getting some sort of dot. So what my model is going to predict. So this is my let's say wickets, and this one is my let's say the runs. So the person who takes less wickets, okay, but score good runs means he is a batsman. So my model is going to categorize whether he is a batsman or he is a bowler. It means in this kind of machine learning model, we do not have the label data. We do not know what is the output for a particular input. So based on the data set we have and the features we selected, the model is going to predict or categorize uh, the clustering problem. So it will cluster it whether the data belongs to a batsman category or it belongs to a bowler category, like this. Okay. Now next time when I give a particular input, let's say if I give 315, based on this data, the model is going to put that particular based on the data. The data uh, will be categorized or kept or inserted in the similar group, like whether it is a batsman or whether it is a bowler, like this. Okay. So generally unsupervised learning is going to solve the clustering problem. Okay, it solves which problem? Clustering problem. And I discussed about the case of unsupervised machine learning algorithm. Okay, where this is a unsupervised machine learning algorithm where initially I'm going to pass dog image and model will not predict it properly. Let's say model predict that it is a cat image. Here I'm getting the feedback, means my model is not trained properly. So feedback is collected here. Okay, so feedback is collected from the output, right? So I'm going to collect the feedback back, okay? And based on the feedback, my model is again trained, okay? And when I give again some other time when I give the dog image, model is going to predict it. Yes, it is a dog image. So here it is a kind of approach where we do not have the label data, and here the model is trained, machine is trained based on the feedback. Okay, feedback getting or from the result, feedback getting from the uh, past experiments, right? And we are correctly predicting the uh, output. Okay, so these are the three important uh, machine learning algorithms. Some are supervised machines, some machines are trained by making supervised machine learning model, else unsupervised machine learning model or semi-supervised machine learning model. Now there is a very important concept called the deep learning. Now what is deep learning? So my dear students, deep learning is again the subset of machine learning. Deep learning is a subset of machine learning. Now just think about it. Can we make the machine uh, which can we make the kind of machine which will take the decision by its own, and it also think like a human brain, okay? Like we people think, we people take a decisions. So can we make a kind of machine that will take a decision like human brain takes a decision? So this kind of approach is generally called as deep learning approach, where we are going to create a multi-neural network architecture. So here in the deep learning, we are going to let me write it down here. Okay, deep learning. So in the deep learning, we generally create a model. Let's say we create a multi-neural network architecture. Okay, so what this particular architecture will do, this particular model or the network is going to mimic, going to mimic human brain. Okay, now initially see, these are very interesting topic, deep learning approach, where we are trying to design a kind of model, multi-layer neural network model, and that model is going to think like our human brain thinks. This is very interesting part. Okay, so when we do this, we have different kind of techniques. Okay, so in the deep learning, we have the very first approach is ANN, which is artificial neural network. We have second approach CNN, which is convolutional neural network, and we have last approach, which is RNN, where it is a recurrent neural network. Recurrent neural network. Okay, recurrent neural network. Okay, so we have three approaches. One is ANN, artificial neural network, convolutional neural network, and recurrent neural network. Now, when these techniques are used, the very first ANN, whenever we say the problem which includes the kind of numbers as an input. So if we have the input data as a numbers, then the artificial neural network deep learning model is used to solve such kind of problems. So if we have the input data as a numbers, then the ANN technique is used to develop this multi-neural network architecture. Okay, fine. And what about CNN, convolutional neural network? When we have input data is in the form of images. Okay, so when we have the image as a input data, then we are going to use a CNN technique, which is convolutional neural network. Okay, here also we are going to design the kind of multi-neural network architecture which is going to mimic your human brain. Okay, and finally we have recurrent neural network, where this kind of neural network is to be developed when we have the input data is in the form of, like say we have the time series kind of data. This data is changing continuously. Okay, so if, let's say we have at particular time, let's say at particular time t1 we have some data, let's say 82. Again at time t2 we have 83. Again at time t3 we have 84. So the data is changing continuously, and in such kind of problems we can we can go for recurrent neural network. So now let me shortly revise. See, what is deep learning? Deep learning, it is a subset of machine learning. Okay. And number two, deep learning is a kind of approach where we are going to create multi-neural network architecture. Okay. And that architecture will mimic your human brain. So this particular network is going to take a decision. It thinks like a human brain can can think, right? So this is a deep learning approach. So we have three different deep learning approaches. One is artificial neural network, then convolutional neural network, and we have recurrent neural network. Okay. Now let us talk about data science. What is data science? Okay, data science. This is what a technique. See, the data science is a technique which is to be applied to all of these concepts. So data science, to become a data scientist, the data scientist must know the knowledge of deep learning, machine learning, AI application. So finally, these two are important factors. Means it depends on kind of problem. If it is a kind of clustering problem, then the unsupervised machine learning model will be designed, right? Here also we need the understanding of data science. Now this is what it is, a branch of applied mathematics. Data science, it is a what? It is a branch of applied mathematics. So before we give means, what is the input to the model? The input to the model is data set, but data set must be cleaned. It is in the proper format. Okay, the null integer gets removed from the data set. So data scientist has to know, means he knows machine learning techniques, he knows deep learning techniques. Okay, so what the data scientist is going to do? So data scientist, he is going to use some mathematical tools. Okay, like, so mathematical tools like probability. Okay, then we have statistics, then we have linear algebra. These are very important terms. Then we have multivariate calculus. Okay, so these are the different machine learning mathematical tools which are very much important to explore your data. to analyze your data. Let's say we have uh, uh, more than 10,000 record in my data set. Okay, more than 10,000 record, more than 10,000 records. Okay, so how it is to be analyzed? Before giving this data to my model, I have to remove all those null entries. I must have to clean the data. Okay, so pre-processing is to be carried out. So like this, again, these are the different concepts which are used in the model. Okay, when we go to model the machine learning model, like unsupervised deep learning model, we know these kind of concepts. These concepts will help you while designing the model. So data scientists should know all those machine learning approaches, deep learning model, machine learning model. Okay, and he knows about the basic mathematics to perform, to design the model. Okay, the very first is I talked is the probability. Okay, then we will be having uh, calculus, then we have the statistics. So these concepts are very much important when we design the model. When we design a model, either it can be a supervised machine learning model, unsupervised machine learning model, reinforcement learning model, or a deep learning model. In every model, these concepts are very much important to design the model. Okay, so it these are the mathematical tools. So we have the different kind of languages like Python. We have R programming languages. By using those languages, we can perform all these operations. Okay. So we have NumPy kind of packages in the Python, and by using those packages, we can perform the kind of operations. Okay. So data science, it has been applied to machine learning model or as well as deep learning models. Okay, so this is all about today's. I have delivered what is the difference between AI, what is machine learning, deep learning, and the data science. Now let us come to the syllabus part. Let me go to the syllabus. So we are going to learn some mathematical concepts. Okay. Wait a minute. Let me open the. um, we have the syllabus mathematics in the machine learning. See, we are going to discuss the statistics part because these are very much important, and it will help to design the model. Probability, again, this is a mathematical concept. Then random variable, regression is a kind of model, and in order to do optimization in order to optimize the model, we should know the concept of convex optimization. Some methods we are going to discuss, and some gradient descent models we will discuss. Okay, these are the textbooks, and we have the lot of reference books. Okay, so this is all about today's session. I'm going to stop here. Thank you for listening to today's session.
Thank you, sir.